Hey everyone, what I wanted to go over in this little video is just some of the properties of some real numbers. So the whole premise of this video is just go over properties of real numbers, um, show what they are, give an example of a couple, so it kind of illustrates them a little bit for you. So we're going to start off with the commutative property. So the commutative property in layman's terms, says that as long as you're adding two things together, it doesn't matter which order you add them in. So if you wanted to add if you wanted to add A plus B, whether you added A first or B first, it makes no difference. Same thing if you're multiplying two numbers together. So for real numbers, this commutative property always holds true that it doesn't matter if you have a bunch of numbers that you're adding together, the order that you add them in, and if you have a bunch of numbers that you're multiplying together, it doesn't matter which order you multiply them in. So just a quick example, if I say let's just say A is 2 and B is 4. So 2 plus 4 equals 4 plus 2. Let's just fix that a little bit. So 2 plus 4 equals 4 plus 2. 2 plus 4 is 6, oddly enough. 4 plus 2 is also 6. So yeah, they're equal, and it's all pretty straightforward. Now let's use the same example for the multiplication part. B equals 4. So now if I say 2 times 4 is equal to 4 times 2, well, 2 times 4 is going to give me 8. 4 times 2, miraculously enough, is also going to give me 8. So now, me doing this as an example illustrates what's going on. It doesn't prove it. So just keep that in mind. But just gives you a rough idea of what I mean. Note that if I'm doing a mixture of them, I have to use other properties. So this only works if you're talking about adding two numbers, or adding the numbers, or multiplying the numbers, not multiplying and adding them at the same time. Alright, the next thing we're going to take a look at is the associative property. So the associative property kind of extends on the commutative property a little bit, and what it's saying is that, well, if I have lots of different numbers that I'm either multiplying or adding together, then it doesn't matter what order I'm doing that in either. So let's take a look at A is going to equal 2, B is going to equal 3, and C is going to equal 4. So if I take a look at the multiplication property, this one here first, I'm going to have 2 times 3 times 4 is equal to 2 times 3 times 4. So 2 times 3 is going to give me 6 times 4, and this is going to give me 2 times 12. And in both cases, my answer is going to be 24. If I do the same example and use the same thing for the addition side, this time I'm going to go A is equal to 4, B is equal to 5, and C is equal to 2, just so I use some different numbers. So that's for this one. So that's going to be 4 plus 5 plus 2 is equal to 4 plus 5 plus 2. That's going to give me 9 plus 2 is equal to 4 plus 7. And that's going to give me 11 is equal to 11. So as you can see, these properties kind of hold true to actually, they always do hold true, but you can kind of see how you work through those properties. This will help you immeasurably when it comes to simplifying equations later, which is something that you'll get to do a fair bit of. So now, the next thing we're going to take a look at is the whole closure idea. So what that means is if I'm adding or multiplying real numbers, my result will always be a real number. Okay, that happens to work really well for real numbers. Other sets, like the counting numbers, for example, you can end up with some issues with quotients. You can end up with some issues with, because you can kind of land things outside of the ballpark of what's there by doing this stuff. But as long as your numbers here exist inside of the real number plane, so if I had a is equal to pi and b is equal to 0. So I should probably use a different example, but I'll use this one for now. So that'll be pi plus 0, which is equal to pi. That's all in the real numbers, no problem. If I do it as a multiplication, it's going to be pi times 0 is going to equal 0. That's going to be still a real number. So let's just try to do a different example. So if we say a is equal to 1.2 and b is equal to 1. So a plus b, which is going to be 1.2 plus 1, that's going to equal 2.2. If we do a times b, that's going to be 1.2 times 1, which is going to equal 1.2. In any case, whatever we do here, as long as these are real numbers to start with, they're going to be real numbers when we're done. All right, on to, oops. Okay, so now we're on to the identity property. The identity property is pretty straightforward. That all you have to do with the identity property is if you're multiplying 1 times any number, that's your answer, whatever the number is. And if you're adding 0 to any number, again, that's your answer. So if we were to say, in this case, a was equal to 22. So 22 times 1 is going to equal 22. And 22 plus 0 is also going to equal 22. Pretty straightforward thing, but still an important property that you'll get to use a fair bit later as you move through some other exercises. So now we go to our inverse property. Our inverse property is pretty much if we take a number and we hit it with its inverse, we get some value. This becomes really useful when we're starting to simplify things, especially more as things get more and more complex later. So if I take a number here, let's just do the same things we did last time, 22. So what I'm saying is that 22 plus a negative 22 is going to equal 22 minus 22, and 22 minus 22 is going to equal 0. So anytime you subtract a number from itself, you will always get 0. Now if I take A times 1 over A, so 22 times 1 over 22, that's going to equal to 22 over 22. When I simplify this, I want to end up with 1 as my answer. So easiest way to think of it, if you have a pizza cut up into 22 parts, and you have all 22 parts, then you have one whole pizza. So that's where your inverse property comes into play. I only have one more left to go through now, and then this video will be done as well. So let's clear that. And now we'll go to our distributive property. Now, take note that when we go to distribute, we can distribute across addition. So we can multiply across addition. We can't really do the add distribution across. We can't do it the other way. It doesn't work. So what this means is if I need to simplify something, this is a way I can simplify it. So if I have A times B plus C, and the B plus C is in brackets, then that's the same as me saying AB plus AC. So let's say A equals 5, B equals 3, and C equals 10. So that means 5 outside of 3 plus 10 is equal to 5 times 3 plus 3 times 10. That's the same as having 5 times 13, and that's the same as having 15 plus 30, and that should give us 45 on each side, assuming that I didn't mess up my addition and multiplication. So that gives you guys a good idea of how that particular property works, and that lets us start to break things out here. So the reason that we want to do that is this will let us simplify these values down by kind of making them a little more manageable for us. Now, sometimes that's not what we need, that's not what we look for, so this kind of does go in both directions. So sometimes you may want to use an identity property later to factor out this A, in which case you take it going this way then. But you'll see those examples as we get into doing some simplifications in the not too distant future. So I hope you found this video helpful. I don't think I got anything else there right now to go through for this one. So I will chat with you guys later. Bye for now.